take notes in your notebook today. So open to the next page in your math notebooks. If you don't have them out yet, then maybe this can be paused and it can wait for you to be ready to start taking the notes. We're going to title this page Lesson 2.2 Notes 2. It's an add-on to what we were doing yesterday. Okay, so Lesson 2.2 Notes 2. The skill we need to practice today, let's write that what our objective is that we're going to be able to write inequalities, to solve word problems. So write inequalities to solve word problems. Not always can a situation in real life be represented with just an equation. We need to represent it with an inequality. So let's make note that where we're going to start, the practice we're going to do today comes from the check it out problem. So check it output. And where we're going to find this is on page 108. So when you look in your notebooks on this page, you can see where did these problems that we worked, what word problems did they come from? Because we're not going to write out the word problems. Okay, and the first one that we're going to do, there are two of them on that page. We're going to do the one almost a little bit close to halfway down the page. So check it out, and we're going to do problem number 2. The recommended dietary allowance, also known as RDA, of iron for a female in Sarah's age group, Sarah's in the age group 14 to 18 years, is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah can consume without exceeding the RDA. So what is the first thing we do with word problems is when we're going to pick a variable to represent the unknown, we describe what that variable is representing. So the unknown in this one is how many more milligrams of iron Sarah can consume. So let's pick M for milligrams. M is additional milligrams of iron Sarah can consume. Not just milligrams. M is additional milligrams of iron Sarah can consume. That's kind of a funny end there. Okay. So once we have described our variable, then we'll use our variable in setting up the inequality. So we'll go to that part where sometimes, remember, there's numbers in there you don't even need. Such as, does it matter that Sarah's in the age group 14 to 18 years for solving this problem? 14 to 18 is not going to be included. What is important is the recommended amount is 15 milligrams per day. She has consumed 11. We need to show how many more she can consume without going over that recommendation. So she's consumed 11. How many more can she? So plus those additional milligrams of iron. So 11 plus the additional milligrams of iron she can consume cannot be any more than, but can be 15. The recommended amount is 15, so is less than or equal to 15. So she doesn't have to consume the recommended amount, but if she wants to, how many more milligrams would she, what are some of the milligrams that could be included? if she wants to at least get closer to it. Okay, so we're going to go with what we were doing yesterday, solving these. We have an addition going on, so we're going to subtract 11 from both sides. And our m will be by itself is less than or equal to 15 take away 11, 4. Now, we have to think about what this is telling us. This is telling us that the extra number of milligrams of iron that she can consume can be 4 or less. It says m is less than or equal to 4. Now, when we think about on the number line, all the numbers that are less than, let's get our number line set up here. Okay, let's just do this. Let's think about this. If we talk about that, what we're going to show now on this number line is that 4, she can consume 4. She can also consume something less than 4. So she could do like this, right? But when we think about all the numbers, if we kept going to the left on the number line, eventually we would get into negative territory. So we don't want to include negative numbers, so we're going to write a restriction for this one, like I talked about a couple of days ago. The restriction for this one would be where m, so we would say, we'll just write that out in words, where m is not negative. Okay, so we don't want m to be a negative number because there's not such a thing as a negative number of milligrams. So we could still show the graph like we do, but then basically we're saying to the reader, when you look at that graph, you got to stop when you get to the negative numbers. Or another way to do it is if you don't want to have to write this out in words, we could show it like what are the actual values that would be included. She does not have to do any more milligrams of iron, so it could be 0. She can do 4, and she can do anything between 0 and 4. So we could show the graph like this instead. And then we wouldn't have to use the words along with our graph where m is not negative. So we would have to do show it one way or the other. Okay? So let's go on to the one at the bottom of the page, number 3. Okay? So number 3, which is at the bottom of the page. We have Josh has reached his goal of 250 pounds and now wants to try to break the school record of 282 pounds. Write and solve an inequality to determine how many more pounds Josh needs to break the school record. Okay, so let's pick a variable. Let's call it P this time, because P is going to actually represent pounds. So this would be, P is, it says how many more pounds, so this is like our last one, is additional pounds Josh needs to break the record. Okay, so P is additional pounds Josh needs to break the record. Okay, so now let's go and figure out an algebraic inequality that could represent that. So he's reached his goal of 250 pounds. The school record is 282. But what if he wants to break it, or what would he have to do? So we're going to say that he's already reached this. He has 250. How many more does he need? And if he wants to break the school record, it's going to have to be at least 282. So at least would be is greater than or equal to 282. Okay, and now we can solve this. We'll subtract 250 from both sides. And we'll see that the number of additional pounds Josh needs are not 282 take away 50, 32. So 32 pounds would actually tie the record. No, it says to break the school record. Yeah, 282. Oh, you know what? We can't include the equal to sign this time. If he wants to break it, he can't have 282 pounds. So we need that equal to bar out of there. To break it, not tie it, he needs to have an additional 32 pounds, more than 32 pounds. So anything over 32 pounds, this is saying would break the record. So let's do our number line graph. We have 32, integer neighbor to the right, 33, integer neighbor to the left, 31. We have our circle at 32. 32 would tie the record, so we can't include that. He wants to break it, so we need all these numbers that are greater than 32 to be represented. Now, are there any restrictions this time? Do pounds have to be in whole numbers? No, he could lift 32¼ pounds and he would break the record. So we don't have to restrict it to a whole number. Eventually, probably could really humanly not lift, too many pounds, but we don't know where his limit is, so we're just going to leave it as it is. Okay, so this is what you're going to add to your skills that you'll practice today, being able to set up your own inequality and show it with the algebraic solution and the graph. Okay, so, oh, and you know what, the other thing we're supposed to do, and I didn't do this on the last one, so we'll make sure we do it on this one, a sentence answer. So, Josh needs, what does this tell us? What does this show us? Josh needs to bench press more than, now, 32 pounds. Remember, we can use the number, but we don't do any other abbreviating. 32 pounds to break the school record. Okay, so our sentence response. So, and we should have done that on the other one also. So make sure in your homework that you do sentence answers for these. Josh needs to bench press more than 32 pounds to break the school record. That's what our algebraic inequality shows us. That's what our graph shows us. And here we are answering the question to our real world problem in a sentence. Okay, so again, this is what you'll be doing, along with maybe some of what we had done previously. Okay, have at it.